Yeah, hi everyone, welcome to PrepFusion. So you would have seen the thumbnail, you would have seen the title. On the title it is saying total probability and Bayes theorem. But in the whole lecture you would see that I will never ever use the word total probability and Bayes theorem. Okay. So sir, how we are studying it? You need to have some patience in this video for next 30-40 minutes. After that every picture will be clear to you. Just have some patience. In the initial 5 to 10 minutes you might feel like that, sir, what is going on? Are we studying total probability or we are studying some different topic? But once we are done with the chapter, once we are done with the first 30-40 minutes, after that you will realize that yes, we were studying total probability only, yes, we were studying Bayes theorem only, because you might have already studied it, you are struggling in this particular topic, that's why you are here, right? So let's have some patience, watch whatever that I am saying. It might be a different way, but it is the most effective way. You would realize that. Okay, so you will understand it surely, but have some patience. So let's get started. Okay, so let's just say this is some system I am having. What is the meaning of system, sir? System could be anything. It could be your laptop, it could be your mobile, it could be your TV, it could be your AC, it could be your fan, it could be anything. You are also a system. What is the meaning of system? System means you can apply some input and it will give you some output. We have seen the functions, no? With respect to value of x, we get some value of y, and y is a function of x. So that's the same thing here. So what does that mean? That, sir, if I apply a input x1, then with respect to input x1, I can either receive y1 or I can receive y2. What does that mean? That means, sir, if I am applying input x1, then, sir, either I can receive y1 or I can receive y2 with different probabilities, y1 or y2. Here what I will write down? Here I will write down probability of receiving y1 given that x1 was sent. Okay, probability of receiving y1 given that x1 was transmitted. Here which word I will use? Transmitted. And here what word I will use? Received. So this will be probability of receiving y1 given that x1 was transmitted, and this would be written as probability of receiving y2 given that x1 was transmitted. So on this arrow, y2 by x1 would be written, y1 by x1 would be written. So what is the meaning of all those things? Everything will make sense, just have some patience. Now I can transmit another signal which is x2. Okay, I can transmit some other input which is x2. So if I am transmitting x2, then again either I will receive y1 or I will receive y2. Let's just say I am receiving y1 here with the probability of 0.4, then y2 I will receive with the probability of 0.6. What does that mean? Probability of receiving y1 given that x2 was transmitted is 0.4. Probability of receiving y2 given that x2 was transmitted is 0.6. So here on the arrow what I will write down? Probability of receiving y1 given that x2 was transmitted, probability of receiving y2 given that x2 was transmitted. And the similar thing can happen with x3 as well, that when you are transmitting x3, sir, either I can receive y1 or I can receive y2. So when you are transmitting x3, sir, either you would receive y1 or you would receive y2. On the arrow what you will write down? On the arrow, sir, I am writing down probability of receiving y1 given that x3 was transmitted, and probability of receiving y2 given that x3 was transmitted. Okay. Now if I say y1 has received, I know that y1 has been received. So this y1 can come from where? Sir, y1 can come either from x1 or it can come from x2 or it can come from x3. So y1 can come from x1 as well, it can come from x2 as well, and it can come from x3 as well. Although on the arrow always you are writing down one thing only, y1 by x1, probability of receiving y1 given that x1 was transmitted, probability of receiving y1 given that x2 was transmitted, probability of receiving y1 given that x3 was transmitted. On the arrow is going from x3 to y1, that means probability of receiving y1 given that x3 was transmitted, probability of receiving y1 given that x2 was transmitted, probability of receiving y1 given that x1 was transmitted. Understandable? Same goes with y2 as well. That, sir, if you are receiving y2, it would either come from x1. As of now you might feel like that, sir, what is going on, but have some patience. After some time every picture will be clear to you. So y2 can also come from x1, it can come from x2 as well, and it can come from x3 as well. So what you will write down here? Probability of receiving y2 given that x1 was transmitted, probability of receiving y2 given that x2 was transmitted, and probability of receiving y2 given that x3 was transmitted. So what is our system? Our system is x1, x2 and x3 are the input, and our outputs are y1 and y2. So when you are sending x1, you can either receive y1. When you are sending x1, you can either receive y1 or you can receive y2. When you are transmitting x2, you can either receive y1 or you can receive y2. When you are transmitting x3, you can either receive y1 or you can receive y2. On these arrows, what you will write down, that you already know. Probability of y1 by x1, probability of y2 by x1, probability of y1 by x2, probability of y1 by x2, probability of y2 by x2, probability of y1 by x3, probability of y2 by x3. So this is known as probability flow diagram. What it is known as? Probability flow diagram. Probability flow diagram of our system. Probability flow diagram of our system. So this is known as probability flow diagram. Now this system is given. Now the question that is asked to you is that, sir, find the probability of receiving y1. First of all, you let me know, is that understandable to you? Sir, if I am sending x1, I can either receive y1 or y2. If I send x2, then I can either receive y1 or y2. Sir, if I send x3, I can either receive y1 or y2. Here on the arrow, what I am writing down? I am writing down the conditional probability. Receiving y1 given that x1 was transmitted, receiving y2 given that x1 was transmitted. In that manner, I am writing down the probability. Sir, if you are receiving y1, it could either come from x1 or it could come from x2 or it could come from x3. Sir, if I am receiving y2, it could either come from x1 or it could come from x2 or it could come from x3. Understandable? And then I joined the diagram and this is what I am getting. This is your probability flow diagram. Now they are asking, find the probability of receiving y1. This I will write down as P of y1. Find the probability of receiving y1. What that probability will be? Let me know from where y1 can come. Y1 can come from x1, x2 and x3. So can I write it down in this way? Probability of transmitting x1, TR means transmitting x1 and receiving y1. Rx means receiving. Or probability of transmitting x2 and receiving y1, or probability of transmitting x3 and receiving y1. Will that show the probability of receiving y1? Say yes or no. How can you receive y1? Sir, if x1 is transmitted and y1 is received, or if x2 is transmitted and y1 is received, or if x3 is transmitted and y1 is received, then you will receive y1. So this will show the probability of receiving y1. Okay. So let me tell you that what I mean, that probability of transmitting x1, probability of transmitting x1. What this is? Probability of transmitting x1, probability of transmitting x1, transmitting x1. It would be written as P of x1. Okay. From next time onwards, I will write down P of x1. And probability of receiving y1 means P of y1 I will write down. So can I write down in this way? Probability of receiving y1 would be nothing but probability of sending x1 and sending or transmitting x1 and receiving y1, or probability of sending x2 and receiving y1, or probability of sending x3 and receiving y1. Can I write it down in this way? Absolutely, sir. So this is the one answer that you are getting. And can you write down another way of it? Sir, probability of receiving y1 would be nothing but probability of x1 intersection y1 could be written as, it is x1 and y1. What does that mean? Probability of x1 multiply with the probability of y1 such that x1 has already occurred. Or what I would say, probability of sending x1, probability of transmitting x1 multiply with the probability of receiving y1 given that x1 is already sent, plus probability of this we have already seen, no? This we have already seen in the previous video. How probability of x2, how probability of A intersection B could be written. Probability of occurrence of event A and B is given as probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred. This is how we write down. So similar thing we are doing here. Probability of receiving probability of transmitting x1 multiply with probability of receiving y1 given that x1 is already transmitted. Probability of receiving, probability of sending x2 multiply with the probability of receiving y1 given that x2 is already transmitted, or probability of transmitting x3 multiply with the probability of receiving y1 given that x3 is already transmitted. There you go. This is your probability of receiving y1. So do we need to remember the formula? Absolutely not. You will be able to understand it in a better way, but as of now we are just deriving the formula that what is the probability of receiving y1. Probability of receiving y1 is probability of sending x1 multiply with probability of receiving y1 given that x1 was already sent, or probability of sending x2 multiply with probability of receiving y1 given that x2 was already sent, or probability of sending x3 multiply with the probability of receiving y1 given that x3 was already sent. Now what is the probability of receiving y2? So y2 can be received from where? Y2 could be either received from x1 or from x2 or from x3. Y2 could be coming from x1 or x2 or x3. So it could be written as same in this way, but I am directly writing the result. What could be the result? That you are sending x1 and receiving y2, or you are sending x2 and receiving y2, or you are sending x3 and receiving y2. Or it could be written probability of sending x1 multiply with probability of receiving y2 given that x1 was sent, or probability of sending x2 multiply with probability of receiving y2 given that x2 was sent, or probability of sending x3 multiply with probability of receiving y2 given that x3 was sent. This is your probability of receiving y2. I am writing down p of y2, but you should know what is the meaning of p of y2. P of y2 is simply probability of receiving y2. P of x1 is probability of transmitting x1. So what you have got? This is what we have got. Probability of receiving y2. Now, do you understand a simple thing that, sir, you don't need to remember the formula. With the flow diagram, sir, you will be easily able to solve it. Let's just say this is your flow diagram. No, this is your probability flow diagram. This is your actual probability flow diagram. Right. So with respect to flow diagram, it will be very easy for us to understand. This has been already made. Probability flow diagram has been already made. Now, what about probability of receiving y1? If I need to make the diagram only for y1, then what kind of diagram would be there, sir? This diagram would be there, because, sir, y1 could be either received from x1 or x2 or x3. So I am making the diagram only for y1. This is the diagram that I have made only for y1. Now one more thing I will do here. In front of x1, no, here I will write down probability of sending x1. Here I will write down probability of sending x2, and here I will write down probability of sending x3. Do you remember the answer? The answer was, sir, probability of sending x1 multiply with probability of receiving y1 given that x1 was sent, or probability of sending x2 multiply with probability of receiving y1 given that x2 was sent. So basically you would have made this diagram, then you would see that, sir, p of x1, what you would see, sir, what is the path of y1? Y1 can come from where to where? Sir, y1 can come either from this, or it can come either from x2, or it can come from, sir, from x3. There are three paths to reach y1. Three paths are there, sir, either x1 or x2 or x3. Sir, corresponding probabilities are written, these probabilities are written, these probabilities are written, and these probabilities are written. These three probabilities are written. Just simply multiply them with these probabilities. Here some probability would be written. Let's just say 0.2, 0.3, and 0.5. So 0.2 multiply with this probability, that would be, let's just say this is 0.7. So 0.2 multiply with 0.7. Let's just say this is 0.2. So 0.7 multiply with 0.2 plus 0.2 multiply with 0.3, and let's just say this is 0.1. So 0.1 multiply with 0.5, or it could be anything else as well. It could be 0.3 as well. Okay, 0.3 multiply with 0.5. So that will be the probability of receiving y1. That's it. So in this diagram, if we do, let's not change this diagram. And if we see this diagram, can you let me know what is the probability of receiving y1? The probability of receiving y1 would be probability of sending x1 multiply with probability of sending x1 multiply with this probability. Basically, you see this path and multiply the corresponding probabilities. P of x1 multiply with P of y1 by x1. Then you see the next path. What is the next path? This is the next path. P of x2 multiply with P of y1 by x2. Then you see the next path. P of x3 then multiply with P of y1 by x3. This is your probability of y1. Similarly, just by looking at this diagram, can you write down probability of y2? Not by any formula, nothing, just by looking at the diagram, probability of receiving y2. So that would be, sir, y2 could come from x1, or it would come from x2, or it would come from x3. So multiply with the probability of this probability, multiply with the corresponding probability, which will be probability of y2 by x1. Then, sir, what is the next part? Next part is this. So probability of x2 multiply with the probability of y2 by x2. Basically, this probability multiply with the corresponding probability, which is y2 by x2, plus probability of x3, this probability multiply with the corresponding probability of y2 by x3. This is the answer. Understandable? So this is how you can write down these probabilities. We will solve a numerical. Now every picture will be clear to you, that sir, why you are spending so much of time. Everything will be clear to you. Let's just say this question is coming, that there are 3 boxes A, B and C. 3 boxes are there, A, B, C are there. In box A there are 5 red ball, 1 blue ball. 5 red ball, 1 blue ball. In box B there are 2 red ball, 4 blue balls. And in box C there are 3 red ball and 3 blue balls. What you need to do, you are selecting one of the box at random, and the ball is drawn from there, and a ball is then drawn at random from the selected box. Find the probability that the ball is red. What you are doing, you are one of the box you are selecting. It's not that, sir, from each box I am taking one ball. No, randomly you are selecting one of the box. Let's just say I selected box B. When I selected box B, from here what is the probability of getting a red ball? That will be 2 by 6. Let's just say I selected box C. From box C, what is the probability of getting a red ball? That is 1 by 2. Let's just say I selected box A. From box A, what is the probability of selecting the red ball? That is, sir, 5 by 6. What I am saying is that probability of selecting red ball given that box A was selected. What is the probability? Probability of selecting red ball given that box A was selected, the probability is 5 by 6. Probability of selecting red ball given that box B was selected. What is that probability? That is 2 by 6. And probability of selecting the red ball given that box C was selected, what is that? 1 by 2 or 3 by 6. Let's write down 3 by 6. The probability is 3 by 6. Now 3 boxes are there. What is the probability of selecting box A? What is the probability of selecting box A? What is the probability of selecting box B? What is the probability of selecting box C? Let's just say there are 3 boxes in front of you. What is the probability that you will select this box? That will be 1 by 3. What is the probability that you will select this box? That is also 1 by 3. And what is the probability that you will select this box? That is also 1 by 3. Now can you think of the diagram? Here you notice 2 activities. One of the box is selected at random, then a ball is drawn. And then you need to comment on the color. You need to comment on the color, whether red or blue. So what you are doing, basically you are having 3 boxes A, B, C. A, B, C. When you select box A, you can either get a red ball. When you select A, you can either get a red ball or you can get a blue ball. So you can either get a red ball or you can get a blue ball. So either you can get a red ball or you can get a blue ball. When you select box B, either you can get a red ball or you can get a blue ball. When you select box C, either you can get a red ball or you can get a blue ball. Now let me know what are their corresponding probability. Probability of selecting box A is 1 by 3. Probability of selecting box B is 1 by 3. Probability of selecting box C is also 1 by 3. Probability of getting a red ball. Probability of getting a red ball given that box A was selected. What was written here? On here, what will be written? Probability of selecting a red ball given that box A was selected. What is that? Probability of getting a red ball given that box A was selected, that is 5 by 6. Probability of selecting a blue ball. Probability of selecting a blue ball given that box A was selected. Probability of selecting a blue ball given that blue. Since it is B, no, so I will write down blue. Probability of selecting a blue ball given that box A was selected. What that would be? 1 by 6. Probability of selecting a blue ball given that box B was selected. What that would be? 4 by 6. And probability of selecting a blue ball given that box C was selected, that would be 3 by 6. So all these probabilities also we know. Although in one diagram it would look very clumsy, but still we are writing down as of now, but we will break it. So probability of selecting a blue ball given that box A was selected, that is 1 by 6, right? That is 1 by 6. The next is this probability of selecting a red ball given that box B was selected, that is 2 by 6. And probability of selecting a blue ball given that box B was selected, that is 4 by 6. Probability of selecting a red ball given that box C was selected, that is 3 by 6, and this probability is also 3 by 6, right? So let's like this diagram is looking a bit clumsy, but I told you that I just wanted to let you know the meaning of this particular thing that we were studying. Everything is making sense now, right? In the initial few 20-30 minutes I told you that it might feel like that, sir, what is going on, but everything will make sense. Okay, you will understand that, sir, these questions are considered as on the tougher side, but we will solve it in the best possible way, and even the toughest problem of JEE Advanced we are going to solve. No matter Bayes theorem, total probability, nothing. This is known as total probability. What we have studied, no, this is known as total probability. But students focus too much on the Venn diagram and all those things, and eventually they mess up. But we will not focus on Venn diagrams, we will not focus on anything. This is how we are going to solve it. Understandable? Well and good. So yeah, now picture is clear that, sir, if I need to talk about only red ball, although from here only you will be able to solve, but sir, let's just say I need to make the separate diagram. If I only need to talk about a red ball, then sir, either it can come from box A, or it can come from box B, or it can come from box C. So probability of selecting a red ball given that it has come from box A is 5 by 6. Probability of selecting a red ball given that it has come from box B, that is 2 by 6. And probability of selecting a red ball given that it has come from box C, that is 3 by 6. Right? And now selecting the boxes, what is the probability of selecting box A? That is 1 by 3. What is the probability of selecting box B? That is also 1 by 3. And what is the probability of selecting box C? That is also 1 by 3. So what is the probability of drawing red ball? Probability of getting red ball, what that would be? That would be, sir, 1 by 3 into 5 by 6, 1 by 3 into 5 by 6, plus 1 by 3 into 2 by 6, plus 1 by 3 into 3 by 6. And can you read it? Can you try reading it? You will solve it, you will get answer. We will also solve it. But can you try reading it? It is like probability of selecting box A multiply with probability of receiving a red ball given that box A was selected, or probability of selecting box B multiply with probability of receiving red ball given that box B was selected, or probability of selecting box C multiply with probability of getting red ball given that box C was selected. That's the scenario. Although this process you don't need to do in the examination hall, you will be very easily able to make the probability flow diagram. How you will be able to make the probability flow diagram? Because you would know that, sir, one of the box we need to select, and then we need to draw the ball which could be either red or blue. That means, sir, left hand side box will be selecting and red or blue. This is how you will make the diagram, and you will be able to get the answer. So 1 by 3 will come common. Here 5 by 6 plus 2 by 6 plus 3 by 6, 9 by 6, right? Eleven by 6 कितना है भाई? 1 by 3 is common, 10 by 6. Okay, so 10 by 18 is the answer, or answer would be 5 by 9. Okay, what is the answer? Probability of selecting red ball is 5 by 9. Can you let me know what will be the probability of selecting blue ball? Sir, if red ball is not being selected, then blue ball will be selected. Then simply it will be 4 by 9. Like basically there are two possible outputs. No, either it would be red or it would be blue. Either it would be red or it would be blue. So if you are not getting the red ball, then you would be getting blue ball. But sir, this is how I will not solve in the examination hall. Let's just say in the examination hall, they are only asking about blue ball. So why would I care about the red ball? What I would do, they are only asking about, sir, blue ball. So what I would do, I would look at this diagram and I will not even care about the red. I would only care about the blue. So blue is coming from here. Blue is coming from here, and sir, blue is coming from here. There are 3 arrows. So from where to where blue is coming? 1 by 3 into 1 by 6. 1 by 3 into 1 by 6. What I mean to say is that, let's just say in the examination, sir, they are talking about only the red ball. Then I would not make this diagram. Are you able to understand this point? If they are talking about only the red ball, let's just say the question was only find the probability of drawing the red ball. This was the question. So if they are talking about only the red ball, then I will make only this diagram. No? Why would I even take care of a blue ball? No, I will not take care of blue ball. Are you able to understand this point? So in the examination, if only they are talking about blue ball, then why would I make these arrows? Why would I make these arrows? I would not make these arrows. I will only care about the blue ball. So blue ball would be coming from A with the probability 1 by 3 into 1 by 6. Blue ball could be coming from B 1 by 3 into 4 by 6. Plus it could be coming from C 1 by 3 into 3 by 6. So 1 by 3 could be taken as common, multiply with 8 by 6. Okay. So what will be the answer? 8 by 18, or it could be 4 by 9. So again, this is not probability of B, it is probability of blue. Probability of blue. So probability of getting a blue ball is 4 by 9. That's the answer. So this is how I will be solving in the examination. From here as well, I can see that if you are receiving red ball with the probability of 5 by 9, then blue ball will be coming with the probability of 4 by 9. So did you understand the meaning of all these discussion that we have done? Absolutely, sir. But one more thing we need to study, just one more thing. What is that? Just one more topic we need to study. Again, sir, same system is given, same flow diagram is given. Probability of sending x1, probability of sending x2, probability of transmitting x3, sending or x3, whatever it is. Probability of receiving y1, probability of receiving y2. Do you know the probability of receiving y1 and y2? Yes, sir. I can write down the probability of receiving y1. I can write down the probability of receiving y2 as well. Now, what they are asking? Do I already know probability of receiving y1 given that x1 was transmitted? Yes, sir. It has been written here. Probability of receiving y1 given that x1 was transmitted. Do I know y2 by x1? Yes. Do I know y1 by x2? Yes. Do I know y1 by x3? Yes. Do I know y2 by x2? Yes. Do I know y2 by x3? Yes. But do I know probability of x1 by y1? No. But do you remember one thing? I told you probability of event A intersection B would be equals to probability of A multiply with probability of B given that A was already there, or probability of B multiply with probability of A given that B has already occurred. Do you remember this? Do you remember this or not? Sir, absolutely yes, sir. I surely remember this. So if you remember this, then what you can do? Sir, probability of x1 by y1 I am supposed to find out. I don't know, sir, what is x1 by y1, right? But I know one thing that, sir, if I need this expression, can I write down in this way? Probability of receiving y1 multiply with probability of sending x1 given that y1 is received would be equals to probability of sending x1 multiply with the probability of receiving y1 given that x1 was received. Say yes or no. Very simple, no? Basically, you can think in this way, y1 getting cancelled, x1 getting cancelled. So in this way, you can think, but you will be able to write down. It is simply y1 intersection x1 I am writing down. Probability of receiving y1 given multiply with the probability of receiving x1 given that y1 was transmitted. That would be equals to probability of receiving x1 multiply with probability of receiving y1 given that x1 was transmitted. So from here, sir, do I know this particular thing? Yes, sir. Probability of y1 I can find out. How will you find out probability of y1? Sir, probability of y1 is very easy. Sir, you have already taught us the formula. It is not a formula. Simple way is there that it could come from x1 multiply with probability of receiving y1 given that x1 was transmitted, plus it could come from x2 multiply with probability of receiving y1 given that x2 was transmitted, plus it could come from x3 multiply with probability of receiving y1 given that x3 was transmitted. This is your y1. So do I know this? Yes. Do I know this? No, I am supposed to find out this. Do I know this? Yes, sir, it will be written here. And do I know this? Yes, sir, it will be written here. So only one variable is there. This you will be able to find out. Job done. That's it. Nothing else is there. Are you able to understand this point? Simply you need to find out probability of x1 by y1. Job done. So what will be probability of x1 by y1? Let's do one thing. Let's keep them a bit downward. I am just writing down what is probability of x1 by y1. Probability of x1 by y1. So eventually you are not going to remember this formula. You are going to derive in this way. Like not derivation, you are going to write down in this way. Probability of x1 multiply with probability of receiving y1 given that x1 was sent divided by probability of y1, right? This is what you are going to see. X1 multiplies y1 by x1 divided by y1. You could have think from here as well, no? You could have think from here as well. Probability of x1 by y1. How you could have think? You could have think in this way. You could have thought in this way that, sir, I could have written this as probability of x1 intersection y1 divided by probability of y1. Right? It is just a conditional probability. No, x1 intersection y1 divided by probability of y1. But then here what you will write down, probability of x1 multiplied by probability of y1 by x1 divided by probability of y1. So this is what you would have written. And now what you can write down? Probability of y1, if you already know, then you can write down the formula of probability of y1 downward. What you can do, downward you can write down the formula of probability of y1. So that would be x1, it could be coming from x1, or sir x2, it could be coming from x2, or sir x3, it could be coming from x3. So there you go. This is the probability. Okay, this is the probability. Understandable? So this is the whole probability, and this is known as Bayes theorem. Okay, this was your Bayes theorem, this was your total probability. But are we going to write down the name? Absolutely not. Because in the examination, will they give the name? No, they will give the question. So you should have the temperament of solving the problem, not the theorem or anything like that. Okay, we never believe in theorems, we never believe in some statements and all. We only believe in problem solving, that how we need to think. That's it. If this is coming in the examination, all what I will think? Probability of x3 by y2. First of all, I will think, do I already know it? My answer would be no, you don't know it. Then I can think in this way, x3 intersection y2 divided by probability of y2. So it could be written as probability of sending x3 multiply with the receiving y2 divided by x3 divided by probability of receiving y2. Now can you write down the probability of receiving y2? Absolutely. Can you write down this probability? Absolutely, you can write down. That's it. What will be the formula? Probability of receiving y2. From here you can write down. Similarly, next question, probability of x2 by y1. First of all, I will think, do I already know it? Answer will be no, you don't know it. So if you don't know it, what you will do? Probability of x2 by y1. Is it there in your probability flow diagram? It is not there in my probability flow diagram. Then what I would do? Probability of x2 intersection y1 divided by probability of y1. That would be equals to probability of x2 multiply with probability of receiving y1 given that x2 was transmitted divided by probability of y1. That's it. x3 by y2, x2 by y1. This is how we are supposed to solve. Understandable? Job done? Okay. So let's see the question now. Again the same example, ditto same example, everything we already know, flow diagram, everything we already know. Now what they are saying, given that it is given that the ball drawn is red, then what is the probability that it is coming from box B? What you are supposed to find out? The ball drawn is red. It is given that ball drawn is red. Ball drawn is red. What is the probability that it is coming from box B? This is what you are supposed to find out. Do I already know it? No, I don't know it. What all things I know? Probability of receiving red ball, that I know. What is that? 5 by 9. In the last question we solved it, it came out to be 5 by 9. Probability of receiving red ball, that is 5 by 9. Probability of receiving blue ball, do I know it? Yes, sir. It came out to be 4 by 9. Do I know probability of, given that I am selecting box A, probability of receiving red ball, do I know it? Yes, sir. What was that? 5 by 6. Probability of receiving red ball, given that box B was selected, do I know it? Yes, sir. It is 2 by 6. And probability of receiving red ball, given that box C was selected, do I know it? Yes, sir. It is 3 by 6. Probability of receiving blue ball, given that box A was selected, 1 by 6. Probability of receiving blue ball, given that box V was selected, 4 by 6. And probability of receiving blue ball, given that box C was selected, yes sir, that is 3 by 6. I know all these things, and this also I know by the probability flow diagram, right? Now this is what I am supposed to find out. So that would be, sir, probability of blue intersection red divided by probability of red, and would be equals to probability of red, probability of sorry, it is not blue, it is box B, sorry, probability of selecting box B multiply with probability of receiving red ball such that box B was selected, divided by probability of selecting red ball. So probability of receiving blue ball given that probability of selecting box B given that the selected box was, sorry guys, probability of selecting box B given that the selected ball was red, that would be equals to probability of selecting box B, that is 1 by 3, multiply with probability of selecting red ball given that box B was selected, that is 2 by 6, divided by probability of selecting red ball, that is 5 by 9. Okay, so what is the answer? 2 by 18 into 9 by 5. So answer will be 1 by 5. So what is the answer? For the first question, probability of the ball coming from box B given that the ball was red, that is nothing but 1 by 5. That's the answer. This is how you are supposed to solve. Is that clear to you or not? Say yes or no. So answer is 1 by 5 here. Okay, the answers are written here, but one more question we are supposed to solve. Next question, if the ball drawn is blue, what is the probability that it is coming from box C? If the ball drawn is blue, what is the probability that it is coming from box C if the ball drawn is blue? Sir, how we will find it out? So I know that probability of getting a blue ball multiply with probability that it is coming from box C given that blue ball is selected would be equals to probability of selecting box C multiply with probability of selecting box C given that it is coming from probability of selecting box C given that we are getting probability of getting a blue ball multiply with probability of selecting box C given that we have already received blue ball would be equals to probability of selecting box C multiply with probability of receiving blue ball given that we have already selected box C. They will be equal, right? Now I know all the things. What all things I know? Probability of getting a blue ball will be nothing but 4 by 9. Multiply with this I am supposed to find out. Let's just say this is X. So this I am supposed to find out. Would be equals to probability of selecting box C, that is 1 by 3. And now such probability of getting a blue ball such that box C was selected. Probability of getting a blue ball such that box C was selected, that is 3 by 6. Okay. So answer will be 1 by 6 into 9 by 4 because 3 and 3 is getting cancelled. 1 by 6, this will come here, it will become 9 by 4. So answer would be 9 by 24. Answer is 3 by 8. So probability of selecting box C given that blue was already selected, that is 3 by 8. There you go, job done. Okay. So nothing else was there, although here deliberately I wrote down this formula. I never believe in writing down this formula. Okay. I always believe by going this process. I always go by this process. Okay. So in the examination I would have gone by this process. This is how I would have solved it. Because very easily I will be able to write down blue, then C by blue, then C multiply with blue by C. So C getting in that manner I will be able to write down. So answer will be 3 by 8. So always I will go with this process. Although in the examination, let's just say I don't know this, then first I will make the probability flow diagram. Okay, this probability flow diagram I will make for only the red case or only for the blue case. Then I will make the probability flow diagram and then I will find out this value, probability of selecting blue ball or probability of selecting red ball. Although same data we are taking, that's why we don't need to make the diagram again and again. Well and good. Let's solve more questions. So we are going to solve a lot of questions. This is first question, then second question, third question, fourth question, fifth question, sixth, then 7. Yes, 7 questions are there. These are some mixed questions. So 7 questions are there on total probability and Bayes theorem. So we will treat them as a separate question, that sir, if this question is coming in the examination hall, how I will be solving it. We don't know whether it is from Bayes theorem or total probability. I don't know anything. Just this question is given that a box contains 3 coins. One coin is fair, one coin has heads on both of the faces, and the third coin is biased such that the probability of obtaining head on one toss is 1/3. Okay, a coin is selected at random. So you see the activity, a coin is selected at random. First of all, you are selecting a coin, then you are tossing it. Coin is selected, then you are tossing it, and then you are supposed to find out the outcome is head. Right? You need to find out the probability such that outcome is head. So what you need to care about? First of all, you need to care about a coin selected, a coin being selected, a coin being selected. This is what you are supposed to. This is what you are supposed to care about. And second one is toss is head. These things you need to care about. So first of all, can you let me know what will be the probability of selecting coin C1? What will be the probability of selecting coin C2? Let's just say you are given 3 coins. What is the probability that you will select this coin? That will be 1/3. What is the probability that you will select this coin? That is also 1/3. And what will be the probability that you will select this coin? That will also be 1/3. Selecting the coin is an independent process. Now, what is the probability of getting a head if I select the coin C1? What is the probability of getting a head if I select a coin C1? What that would be? If you select coin C1, 1 is fair coin. Coin 1 is fair coin. This is the first coin is fair. There are 3 kind of coins: fair coin and head on both side, head on both, and it is having tail and head, but the probability of head being 1/3. So here probability of tail will be 2/3. So these kind of 3 coins are there: first coin, second coin, and this is the third coin. So probability of getting a head such that coin C1 is selected, that will be 1/2, right? Because it is a fair coin. Now you let me know probability of getting a head such that C2 are selected. What will be the probability? Sir, this coin is having a head on both of the faces. That means probability will be 1, because for sure head will be coming. No, if I am telling that on both of the faces there is head, and if I toss the coin, what will come? You will say, sir, surely head will come, right? Head came on 19th of November in 2023 in Ahmedabad ground. He should not be there. He should not have been there. Otherwise, our life would have been a bit more happier. Yeah. So probability of getting a head such that coin C3 is selected. So coin C3 is selected. This is coin C1. This is coin C2, and this is coin C3. So coin C3 is selected. What is the probability of getting head? That is 1/3. Right? Understandable? Now what you are supposed to find out? You are supposed to find out probability of getting a head. You can make a flow diagram as well, but without the flow diagram as well, we are able to understand. 3 coins we are selecting, and we need to care about probability of getting head. 3 coins we are selecting, we need to care about probability of getting head. So probability 1/3, 1/3, 1/3 are there, and here what are the probabilities? These probabilities are 1/3, 1/3, 1/3. Here probability is 1/2. If I select coin C1, what is the probability of getting head? Here probability is 1, and here probability is 1/3. So 1/3 into 1/2. Probability of selecting coin C1, or let's write down in this way: C1 multiply with getting head such that C1 is selected, or C2 multiply with getting a head such that C2 is selected, or C3 multiply with getting a head such that C3 is selected. So 1/3 into 1/2, 1/6. 1/3 into 1, 1/3. 1/3 into 1/3, 1/9. What is the LCM? 18. 3, 6, 2. 11/18. That's it. This is the answer. Very easy question. In the examination, I will directly write down this step. Okay, I would directly see that, sir, fair coins are being selected. Directly I would see, sir, probability will be 1/2. Here it would be 1/2. Here it would be 1. Here it would be 1/3. Then I would see, sir, I need to get the head. So how I can get a head? Tossing the coin C1, getting a head on this. Tossing a coin C2, getting a head on this. Tossing a coin C3, getting a head on this. So if you have enough practice, then directly you can write down this line. Otherwise, have patience and you can make this diagram and you will be able to get the answer. So you will be able to, surely you will be able to solve the problem. There is no doubt in that. Okay, very straightforward. Just as you read the question, you will realize that yes, sir, here I need to make the flow diagram. Understandable? Next question. In a manufacturing bolt, there are 3 machines A, B, C, which are producing 25%, 35% and 40% of the total output respectively. That means total output is 100%. 25, if you are making 100 machines, no, if you are making 100 machines, then 25 machines is coming from A, 35 machine coming from B, and 40% machine coming from C. It is known that 5%, 4% and 2% of the bolts produced by machines A, B, C are defective. Okay, a bolt is selected at random from the factory. Bolt you are selecting at random from the factory's total production, and it is found to be defective. It is found to be defective. Find the probability that defective bolt was manufactured by machine B. So probability that defective bolt was manufactured by machine B, given that when you have selected a bolt, it was found to be defective. The bolt has found to be defective, then find the probability that it is coming from B. This is what you are supposed to find out. What you can comment now. That sir, what is the probability of bolt coming from machine A? What is the probability that a bolt is coming from machine A? So that is 25%, that means that is 0.25. Sir, what is the probability that a bolt is coming from machine B? So that is 0.35. And sir, what is the probability that bolt C is coming from machine C? Sorry, bolt is coming from machine C, that is sir 0.40. Now sir, what is the probability that bolt is defective given that it is coming from machine A? What is the probability that bolt is defective given that it is coming from machine A? That is sir 0.05. What is the probability that bolt is defective given that it is coming from machine B? So that is 0.04. And what is the probability that bolt is defective given that it is coming from machine C? That is 0.02. Is that clear to you? This much information is given. What is given that we have find out? What is given that we have written? Now what we are supposed to find out? We are supposed to find out this value. Are we given this value? No. But we know one thing. Probability of bolt being defective multiply with the probability of B by defective would be equals to probability of B multiply with the probability of B by defective. Do I know this value? Yes sir. Do I know this value? Sorry. Defective by B. Sorry guys. Defective by B. Do I know this value? Yes sir. What is this value? Probability of B, that is 0.35. This is 0.35. And what is this value? This value is 0.04. Do I know this value? I am supposed to find out. Okay, I don't know this value, but let's just say this value is X. This value is X. This value I am treated as X. I am treating this value as X because this is what I am supposed to find out. No? So this value I don't know, and this value is X only. Now what you are supposed to find out? You are supposed to find out only one thing. What is the probability of receiving a defective bolt? What is the probability of receiving a defective bolt? So without making the tree diagram, can you make it? Without making the probability flow diagram, can you write down the answer? Probability of receiving a defective bolt without making the diagram. Or you can make the diagram as well. Do we have to add a page? Yes, we will have to add a page. You can make the diagram as well. If you want to make a diagram, you can make a diagram as well. But directly you can say defective would be sir A into probability of A multiply with defective by A. Right? Directly you can see, or you can make a probability flow diagram as well. That there are three machines A, B, C. A, B, C. They will manufacture 25%, 40%, no 35% and then 40%. 35% and then 40%. And we need to care about only defective, right? Then probability that defective coming from A, that would be defective coming from A, that would be 0.05. Probability that defective coming from B, that would be 0.04. And probability that defective coming from C, that is 0.02. So what will be the probability of defective? So directly I can see here, probability of defective will be 0.25 into 0.05. It is pretty simple, no? 0.25 into 0.025, sorry, 0.25 into 0.05, plus 0.35 into 0.04, plus 0.40 into 0.02. right? So 0.35 into 0.04 plus 0.40 into 0.02. Actually, this problem should have been solved in this manner. Okay, I should have written in this manner: 25 by 100, 5 by 100. Then it would have been easier calculation. But in points, it would become a difficult calculation. No. So whenever it is given in percentage, no, always go with this 4 by 100. Don't write down in points. Okay, that was a error from my side. I should have written in this way. Now the problem looks very much easy, but in points it would look like a complex calculation. So what is the answer? 25 into 5. What that would be? 125. 125 plus 35 into 4. 140 plus 80. 220 plus 125. That is 345. Right? So 345 divided by 1000, or 100 into 100, better I should write down 345 divided by 100 into 100, right? Okay, so what we are getting, what answer we will be getting? So x would be equals to 35 by 100 multiplied with 4 by 100 divided by, let's remove it from here, or let's better what we do is that x would be equals to 35 by 100 into 4 by 100 divided by 345 by 100 into 100. So this 100 into 100 is getting cancelled out. 35 into 4 divided by 345. 35 into 4 divided by 345. That we need to do, and we will get our answer. Right? 35 into 4 divided by 345. So 0.405. 0.405. That will be the answer. Okay? That's the answer that you are getting. So this is how you can solve it. Without even making the probability flow diagram as well, you will be able to solve it. So the approximate answer rounded off to 3 decimal places. That is the answer. This is how we can solve it. Let's go to the next one. Think about it. Here a bit of brain you need to use, but you will be able to solve this question. For sure you will be able to solve this question. Just a bit of a brain you need to use. So first of all, you will read the last line that he answers correctly with the probability 1. Given that answer marked is correct. You read the question fully on your own. That in a multiple choice question is there, multiple choice test question is there with 4 options. Exactly one option is correct, and he can do one thing: either he may guess the answer, or he may copy the answer, or he knows the answer. Okay, so guessing the answer, probability of guessing the answer, that is 1 by 3. Probability of copying the answer, that is 1 by 6, and this is given. Probability of guessing the answer is 1 by 3. Probability of copying the answer is 1 by 6. Now only 3 process he can do. No, probability of guessing the answer, or probability of copying the answer, or probability of knowing the answer. Probability of knowing the answer, that would be equals to 1. What is this? Probability of knowing the answer. Knowing the answer. Knowing the answer. Because only 3 things he can do. Either he can guess, or he can copy, or he knows the answer. So probability of knowing the answer will be what? That would be equals to 1 minus 1 by 3 plus 1 by 6, and that would be equals to 1 by 2. So probability of knowing the answer is 1 by 2. Right? Now what is given? It is known that his answer is correct given that he copied. Probability of getting the corrected answer. So probability of getting the corrected answer, I will write down as R. Okay? Probability of corrected answer. Corrected answer I am showing by R. Corrected answer I am showing by R. So probability of getting a corrected answer given that he has copied. Probability of getting a corrected answer given that he has copied, that is 1 by 8. Now can you let me know probability of getting the corrected answer given that he knows it? Given that he knows the solution, what will be the probability? If you know the solution, then you will get the correct answer with the probability 1, no? If the examinee knows the answer, then he answers correctly with probability 1. So probability of getting the answer correct, given that he knows the answer, that is 1. Now can you let me know what will be the probability of getting the correct answer given that he guessed it? What will be the answer? Probability of getting the corrected answer given that he guessed it, what will be the answer? It is a MCQ question with 4 options and exactly one of them is correct. So you are having 4 options A, B, C, D. If you guess it, what is the probability that you will get a correct answer? That will be 1 by 4, right? Out of only 4, only 1 is correct. So what is the probability of getting the corrected answer? That is 1 by 4 after guessing it. There you go. Is that understandable to you? So this was the beauty here. This was the beauty. Probability of getting the corrected answer given that he guessed it. That is 1 by 4. Probability of getting the corrected answer given that he guessed it. That is 1 by 4. Probability of getting the corrected answer given that he knows it, 1. Probability of giving the corrected answer given that he copied it, that is 1 by 8. So everything we know. That means what the guy is doing, we need to add a page. In that manner, we need to add a page after every question, I guess. So what the guy is doing, either he is guessing the answer, or he is copying the answer, or he is knowing the answer, and he may get the question correct. So what are the scenarios? The scenarios are like this, sir. Probability of getting the corrected answer given that he guessed it. Probability of getting the corrected answer given that he guessed it was 1 by 4. This is 1 by 4. Getting the corrected answer given that he copied is 1 by 8, and this is 1. And here probability of guessing the answer 1 by 3, 1 by 6, 1 by 2. 1 by 3, 1 by 6 and 1 by 2. Okay. So what we are supposed to find out? Everything we know now. What we are supposed to find out? We are supposed to find out given that examiner had marked the, given that the student has marked the answer correct, find the probability that he actually knew the answer. Probability of knowing the answer given that he marked it correct. This is what we are supposed to find out. I know that P of R multiplied with P of Kn by R would be equals to P of Kn multiplied with P of R by Kn. Say yes or no. Do I know this value? I will have to find out this value. What is this value? Let's call this value as x. This value is x. Do I know this value? Probability of knowing the answer 1 by 2. And do I know this value? Probability of getting the answer correct, R by Kn, that is 1. This value is 1. What does that mean? Probability of getting the corrected answer given that he knows it. Given that the aspirant knows it, what is the probability that he will get it correct? That is 1. So I only need to find out P of R. Can I find out P of R? Absolutely, sir. P of R would be nothing but 1 by 3 into 1 by 4, that will be 1 by 12. Plus 1 by 6 into 1 by 8, that is 1 by 48. Plus 1 by 2. (24). 29 by 48. Okay. So this is coming out to be 29 by 48. Multiply with x will be equals to 1 by 2. X will be equals to 24 by 29. There you go. This is the answer. You ask these kind of questions to your fellow friends, they will say that when we studied this topic, no, then I was able to solve it, but now I am not able to solve it. When they study this topic using the Venn diagrams and all, at that time they will be able to understand that, okay, this is the total probability, this is the Bayes theorem, but after some time, no, you will throw this question to them. They will say that I need to revise the notes. Why you need to revise the notes? This is how you follow the process. You will never ever forget it. Just see what is given. If you are able to see what is given, then you are never going to forget these kind of scenarios. Okay, never ever you will have to revise the notes. Just have patience. Just have the good enough aptitude. Simple aptitude you need to have. Probability of getting correct answer. All these things you already know, and then get the answer. 24 by 29. There you go. That's the answer. Okay. So very simple it is. It's just that people study too much about total probability, too much about the theorems, then they mess it up. In the whole lecture, we never wrote down the Bayes theorem word. Okay, it is not a Bayes theorem. It is PrepFusion theorem. Okay, although no disrespect to great people, great mathematician, I'm just telling that this is how it could be understood rather than going by the statements and all. Okay, let's go to the next one. Yeah, sorry for the interruption, guys. Actually, the flow got broken in between. Someone came in between, so flow got broken. So yeah, let's get started. Let's solve this question. So reliability of COVID test is specified as below. The statements are written. All these things are written. First of all, you see what you are supposed to find out. A person is selected at random from this population and undergoes the COVID test. The test result is reported as COVID positive. The test result is reported as COVID positive. Let's just say test result being reported as COVID positive. I am denoting it by D. Okay. Test result is COVID positive. Test result reported as COVID positive. Reported as COVID positive. So this I am showing by D. Okay. And the test result might be, although I don't need to care about COVID negative as well, but let's keep test result reported as COVID positive, that is D. Then find the probability that person is actually having COVID. So I am saying C positive is person actually having COVID. Person actually having COVID. Actually having COVID. So what you are supposed to find out? You are supposed to find out this particular thing. Right? This is what you are supposed to find out. Find the probability that the person is actually having COVID positive, given that the test is also showing COVID positive. Now let's see what is given. Among the people who are actually having COVID, the test correctly detects the disease in 90% of the cases, while 10% of the cases go undetected. What does that mean? There is a person who is actually having COVID. There is a person who is actually having COVID. Okay, and the test is also saying that you are COVID positive. There is a person who is actually having COVID and the test is also saying that you are COVID positive. How many cases are there? 90% cases are there. Are you able to understand this point? So what they are saying, a person who is actually COVID positive and the test is correctly saying that you are COVID positive, they are 90% of the cases. 90% means 90 by 100. They are 90% of the cases. 90 by 100. Say yes or no. A person who is actually COVID positive and the test is also showing COVID positive, that is 90 by 100. Next, sir, why you did not write down about 10%? So that we already know the person who is actually having COVID positive, but the test is saying that you are not COVID positive. Let's just say I define another variable, that is ND. ND I am defining. The test is saying test result reported as COVID negative. Okay, what does that mean? Probability that the person is actually having COVID positive. He is actually having COVID positive, but the test is saying that you are not having COVID positive. What is those chances? Those are 10 by 100. Next, among the people who do not have COVID, 99% reported as COVID negative only. What does that mean? That there is a person who is not having COVID and the test is also saying that you are not having COVID. That is 99%. That is 99%. That is 99%. And there is a person who is actually not having COVID. 1% are incorrectly reported. That means there is a person who is actually not having COVID, but still the report is saying that you are having COVID. He is actually not having COVID, but report is saying that you are having COVID. That is 1% of chances. Is that understandable to you? Why I am not caring about these guys? Why I thought that I should not be caring about this person? Because I need to find out D and C plus. I only need to care about D and C plus. Are you able to understand this point? So if I only need to care about test resulted as COVID positive, that's why I was not considered about this particular guy. You will see that this value will not even be used. That means this value will not be used anywhere. This value will not be used anywhere. You will see it when we solve the problem. Okay. So slowly you will understand that why I was not caring about this guy. Next, in a large population, it is known that 0.1% are COVID positive individual. That means how many people are having COVID positive? 0.1%. 0.1 divided by 100. 0.1%. So how many people are not having COVID? 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 So how many people are not having COVID? That would be 1 minus 0.1 divided by 100. So that would be 100 minus 0.1. 100 minus 0.1 would be 0.999. Right? 100 minus 0.1, this is a very, क्या कर रहा हूँ भाई मैं, 0.999, अरे भाई 100 minus 0.1, so what you will be getting, 999, so 99.9 divided by 100. So I actually wrote down the final result, but this will be that 0.1% guys are actually having COVID positive, and 99.9% guys are 0.1% guys are having COVID positive, and 99.9% guys are not having COVID positive. So what is the meaning of C minus? Person not having COVID, not having COVID. Okay, so this is the meaning of C minus. So is all the values are understandable to you or not? Given that a person is COVID positive and report is also saying that you are COVID positive, that is 90% chances. Given that a person is COVID negative, but still the report is saying that you are COVID positive, that is 1% of chances. The guy is not COVID positive. He came to the hospital, he is not having the disease, but still the report is saying that you are having the disease, that is 1% chance. And the guy who is COVID positive, and the report is saying that you are positive, that is 90% of the chance. Now if there is a guy who is actually COVID positive, but the report is saying that you are not COVID positive, that is 10% of the chance. And there is a guy who is actually COVID negative and the report is also saying that you are COVID negative, that is 99% of the chance. And the probability of having a guy COVID, that is 0.1% of the chance, and probability of guy having not COVID, that is 99% of the chance. 99.9% of the chance. 99.9% of the chance. Is that understandable to you or not? Everything is understandable. What we are supposed to find out? We are supposed to find out probability of C plus by D. This is what we are supposed to find out. So I know that this will be equals to probability of D multiply with probability of C plus by D would be equals to probability of C plus multiply with probability of D divided by C plus. Do I know this value? Probability of having the disease? I don't know this value. This I am supposed to find out. Probability of C plus, do I know this? Yes sir, it is 0.1 by 100. Multiply with probability of D by C plus, that is 90 by 100. So you are supposed to find out only this probability of having the disease. That means there are two chances, sir. Either someone will have COVID positive or someone will not have COVID positive. So sir, having COVID positive and still the disease is detected, or having not COVID positive, still the disease is detected, these probabilities are given. Along with that, this probability is also mentioned. So this is 0.1 by 100. Only 0.1% guys are having it, and this is sir 99.9 by 100, right? 99.9 by 100. And now sir, what is this probability? That you are having COVID positive and report is saying that you are COVID positive, that is 90 by 100. And here you are not having not COVID positive, that means you are COVID negative, but the report is saying that you are having the disease, that is 1 by 100. That you are not COVID positive, but still they are saying that you are having the disease, that is 1 by 100. Is that understandable to you? So what is the probability of having the disease? That is 0.1 by 100 into 90 by 100 plus 99 point. I know a lot of people would have matched up here. Okay, if you matched up here, comment down. That's what I actually matched up here. You need to comment down, because I know that a lot of people will be messing up this calculation. They will write down 0.1 by 100 and they would have written 99 by 100 or 0.99 by 100, whatever they would have written. I have seen a lot of people mess up in this calculation. Okay, a lot of people mess up in this calculation. I know a lot of people would have matched up here. So 0.1%, 99.9%. Okay, so this you take care. So here it would be 99.9 plus 9. This would become 99.9 plus 9, right? Because 0.1 into 9 will be 0.1. This will be 9 plus 99.9 divided by 100 into 100. So 99.9 plus 9 will be 108. 99.9 plus 9 will be 108.9 divided by 100 into 100. Okay, so this is the probability of having the disease. So 108.9 divided by 100 into 100 multiply with x would be equals to 0.1 by 100 multiply with 90 by 100. So this get cancelled out, this get cancelled out. X would be equals to 9 divided by 108.9. So 0.0826. This is the answer that you are getting. Okay, 0.0826, 0.0826, 0.0826. This is the answer that we are getting. Is that question understandable to you? A lot of information would be given, a lot of big paragraph would be given, but will that be a very tough question? Absolutely not. Very easily you will be able to solve it if you just hold on, if you just have some patience that what the question is saying, that report is COVID positive and probability that the person is actually having COVID. So in that manner you need to solve the question. Person actually having COVID, person actually not having COVID, person actually having COVID, still it is showing positive. Sorry, person actually having COVID and it is showing positive, person actually not having COVID, still it is showing positive. These two are the matter of concern. So did you notice one thing, that this is not even used, this guy is not even used, and this guy is not even used, right? Only these two persons were used. This was used and this was used. That's why I was not caring about test result as COVID negative, because I need to care about test resulting as COVID positive. Because if I read the last line, no, I only need to care about test results as COVID positive. Find the probability that person actually having COVID. So person actually having COVID, person actually not having COVID, having COVID detected positive, not having COVID detected positive. These two I need to care about. Job done. That's it. Okay. So this is the answer, 0.0826. Next question. This is a very good question and it is surely coming in future examination. So 3 star I am putting that it is surely coming in future examination. Read the question, very straightforward it is. You will be able to solve in a very easy manner. Okay, just read it. There is a box or bag is there. So there is a bag A which is having 3 white balls and 2 red balls. This is your bag A. And there is bag B which is having 2 white balls and 2 black balls. And this is not red, this is also black only. Now a ball is drawn at random from bag A. From bag A you are putting in bag B. And then a ball is then drawn from bag B, and then a ball is drawn from bag B. From here we are drawing it. This is the scenario that we are doing. Okay. Bag A, bag B, ball you are putting from bag A to bag B, and then from here you are drawing the ball. And it is found to be white. It is found to be white. When you are drawing the ball from here, it is found to be white. Find the probability that ball transferred from bag A to bag B was white. So you need to find out the probability that ball transferred from bag A to bag B was white, given that ball drawn from bag B after transfer was white. So what are the two scenarios? First of all, this is what we are supposed to find out. And what are the two scenarios? That what is the first process? The first process is that you are transferring the ball from A to B. You are transferring the ball from A to B. This is what we are supposed to find out. Transferring the ball from A to B. So the transferred ball either it could be black or it could be white. I am saying that I am making an event x1. What is that? Transferred ball from A to B is white, and I am making an event x2 which is transferred ball from A to B is black. Sir, how did you understand that you need to make these x1, x2? By reading the question that sir, you are drawing a ball from bag B, it is found to be white, then you need to find out that the ball transferred from bag A to B was white. That means what you are supposed to find out? You are supposed to find out You need to find out the probability that transferred ball from bag A to B was white. That means you are supposed to find out probability of x1 divided by probability of ball drawn from bag B after the transfer was white. What does that mean? I am going to make an event y1 and y2 as well. I am making y1 that y1 is ball drawn from B, ball drawn from B after the transfer is white. And again I am making event y2 ball drawn from B after the transfer is blue. So did you understand what I made it? I made it probability of y1 by x1 I am supposed to find out. There you go. So did you understand how did I make it? That what I am supposed to find out. That given that the ball drawn from B after the transfer is white, after the transfer, given that ball drawn from B after the transfer is white, then find the probability that ball drawn from then find the probability that ball transferred from bag A to B was white. So can you let me know what is the value of px1? Can you let me know what is the value of px1? Probability of transferring the ball from A to B and it turned out to be white. That means what is the probability of transmitting a white ball from A to B? P of x1 is probability of transferring a white ball from A to B. Say yes or no. So what is the probability that you can transfer a white ball from A to B? That means how many balls are there? How many total balls are there? 5 balls are there. Out of them, how many of them are white? That is 3 by 5. So probability of transferring a white ball from A to B is 3 by 5. And what is the probability of transferring a blue ball from A to B? That will be 2 by 5. Not blue, sorry, black. What is the probability of transferring a black ball? Did I write down blue? It is black. Sorry guys, it is black. So transferring a black ball from bag A to bag B, what is the probability of that? That probability is total balls are 5, out of them 2 are black. So 2 by 5. So P of x1, P of x2 I know. Now here what I would require, sir, I know that probability of y1 multiply with probability of x1 by y1 would be equals to probability of x1 multiply with probability of y1 by x1. Sir, do I know this value? No, I don't know this value. I am supposed to find out this value. Probability of x1, sir, yes, I am getting to know it is 3 by 5. And what is this? Probability of y1 by x1. Can you let me know what is probability of y1 by x1? Let's read it. Probability of y1 by x1. What that would be? What is y1? Ball drawn from B after the transfer is white. That is y1. And what is x1? x1 is transferred ball from A to B is white. That means you are from A to B you are transferring the ball which is white. Given that you have transferred a white ball. What is x1? x1 is transferring the ball to be white. So given that you are transferring a white ball. So this was the scenario. This was your A. This was your B. 3 white, 2 black. 3 white, 2 black. And 2 white, 2 black. 2 white, 2 black. So given that you are transferring a white ball. Then find the probability that ball drawn from B is white. So you are transferring a white ball. So here how many balls will be, if you are transferring one white ball here, so how many balls you are having here? 5 balls I will be having. And now this will become 3 white and 2 black. So out of them 3 are white and 2 are black. Did you understand this point or not? Say yes or no. So if I make the diagram, did you understand? What is y1 by x1? Given that you are transferring a white ball from A to B, find the probability that from box B, from bag B, you are taking a white ball. Find the probability that you are taking a white ball from bag B, given that you are transferring a white ball from A to B. Now if I make the flow diagram, probability of x1 3 by 5, probability of x2 2 by 5. Now I need to care about only y1. Why I only need to care about y1? Because sir, I need p of y1, I need p of x1, that is already there. Y1 by x1 I already know. So sir, I only need to care about p of y1. So y1 could be coming from here. What is the probability? Sir, probability is 3 by 5. The y1 can come from here as well. With what probability? So that means you need to find out probability of y1 by x2. What is that? Read the statement carefully. What is x2? Given that the transferred ball from A to B is black. Given that the transferred ball from A to B is black. You are transferring the ball black. So what you will be getting here? You will be getting 2 white and 3 black ball. 2 white and 3 black ball. So how many total balls will be there? Total balls will be 5. Then find the probability that ball drawn after the transfer is white. Find the probability that ball drawn after the transfer is white. That will be 2 by 5. Is that understandable to you? So did you understand what we are doing here? I need to care about only y1. What is y1? After the transfer, ball drawn from B is white. This is your y1. So now there are two processes that either you can transfer white ball or you can transfer black ball. Either you can transfer white ball or you can transfer black ball. So I understood that I will make two events x1 and x2, that I am transferring white ball or I am transferring black ball. So here I am having 5 balls, out of them 3 are white. So probability of x1 will be 3 by 5, probability of x2 will become 2 by 5. Now after transferring, after the transfer of white ball is done, then what is the probability? That you are getting a white ball from bag B. What is the probability that you are getting a white ball from bag B? So sir, here 3 white ball will become out of 5, so answer will be 3 by 5. And sir, if you have transferred a black ball from here, so here sir, total balls will be 5, but what is the probability that you will be getting a black ball? Sir, that will be 3 by 5. Sorry, if you have transferred a black ball, then there will be 3 black balls, no? So what is the probability that you are getting a white ball? Because what is y1? Y1 is the probability of getting a white ball. So total balls will be 5 and I need to find out the probability such that the ball is white. So out of 5, 2 balls are white, so probability will be 2 by 5. Is that understandable to you or not? Completely understandable, sir. Surely it is understandable. So I will remove this diagram and next I will write down the probability of y1. It is a very good question. If these kind of questions are coming, then forget about anyone solving these kind of questions. Everyone will be struggling. So surely it is coming in future. Surely, for sure it is coming in future. These kind of questions are coming surely in future. So probability of y1 I can find out. So that would be 3 by 5 multiply with 3 by 5 plus 2 by 5 multiply with 2 by 5. 9 plus 4, 13 by 25. 13 by 25. And this I already know, sir. This is also 3 by 5 only. So sir, x is coming out to be 3 by 5, 3 by 5, that will be 9 by 25 divided by probability of y1, that is 13 by 25. So what is the answer you are getting? Sir, probability of x1 by y1 is 9 by 13. So this is how we are supposed to solve. Okay. So for the first time it might feel like that, sir, what statement are given, sir, how we need to proceed. But slowly when you write down the theory, a bit of theory you can write down in the examination, that sir, what process we are doing. We are transferring ball A from ball B. This is the first process, and then we are drawing a ball from B. So two processes are there. Now sir, drawing the white ball or drawing the black ball, or sir, that will depend on what kind of ball is transferred. That means I will make from box A, from bag A, white ball is transferred, probability is 3 by 5. From bag A, black ball is transferred, probability is 2 by 5. Then probability of drawing a white ball such that white ball was transferred, that will be 3 by 5. Probability of drawing a white ball such that black ball was transferred, that will be 2 by 5. So all these probabilities I would know, then what I am supposed to find out, that I will write down. So first of all, in the probability question, no matter whichever the question of probability is there, first of all, always you should write down what you are supposed to find. So I am supposed to find the probability of a ball being transferred from A to B, that is white. Next question is actually very good. This level of question I don't think can be asked in GATE examination, but who knows, it could be asked as well. So we will take the worst case. If this kind of question is asked in the GATE examination, then how will you solve? This is actually a J advanced problem. Okay, this is a J advanced problem only. This is a very good question actually. So think about it, have some patience and think as much as you can. What is the scenario? That there is a box U1, because here there will be different cases. Here the diagram will be a bit bigger. The probability flow diagram will be a bit bigger. So U1, U2, 2 boxes are there, 3 white balls are there and 2 red balls are there. For U2 there is only 1 white ball. This is the scenario. A fair coin is tossed. If you are getting head, then one ball is drawn from U1, and when it is drawn, it is transferred to U2. And if you are getting a tail, then two balls are drawn. One ball could be drawn, or two ball could be drawn, and it is transferred from U1 to U2. After the transfer, one ball is drawn from U2. One ball is drawn from U2. So after the transfer, the ball is drawn. Okay, after the transfer, the ball is drawn. Find the probability that ball drawn is white. You need to find out probability of ball drawn from U2 after the transfer. Ball drawn from U2 after the transfer is white. This is what we are supposed to find out. Okay. Now, what you can understand from these statements? If head appears, then you are drawing one ball. If tail appears, then you are drawing two balls. Can I say probability of drawing one ball from U2? Probability of drawing one ball from U1, actually. Drawing one ball from U1 and transferring it to U2. Whether the ball will be white, black, blue, that I am not caring about. I am only caring about only one thing. What is the probability of drawing one ball from U1 and transferring it to U2? And what is the probability of drawing two balls from U1 and transferring it to U2? I am asking you a very simple question, that find out the probability of drawing one ball. When I will draw one ball? When I will draw one ball? Sir, when you get head. And when I will draw two balls? When I get tail. So what is the probability when you are tossing a coin? What is the probability of getting a head? So that is 1 by 2. And what is the probability of getting a tail? That is also 1 by 2. The scenario is that, sir, either you will get a head or you will get a tail. When you are getting a head, you are going to draw one ball. And when you are getting a tail, you are going to draw two balls. One ball you are going to draw from U1. All this process is going from U1. And from here you are going to draw two balls from U2. What is the probability? Corresponding probabilities are half only. Now if I draw one ball, the ball could be either white. If I draw one ball, the ball could be either white or it could be red. Either it could be white or it could be red. And if I draw two balls, then the scenarios could be that both balls are white. First ball is white. And when you are drawing two balls, that means you are drawing without the replacement. I told you by default it will be without the replacement. If I am giving you 5 balls and I am asking you draw 2 balls from it, what does that mean? You are doing it without replacement only. From 5 you are drawing 2 balls, so without replacement only, right? So it could be white. First ball is white, second ball is red. First ball is red, second ball is white, or both balls are red. These are the possible scenarios. This scenario you are doing with half probability, and this scenario also you are doing with half probability. So now the question is that what is the probability that you are drawing? I am asking you, what is the probability that you are drawing one ball from U1 and that ball is white? Drawing one ball from U1 and that ball is white. So first of all, and means multiplication. So first of all, I will draw one ball from U1 with half probability, and that ball is white. What is the probability of that? What will be the probability of that? Here 5 balls are there, out of them 3 are white. So probability of that will be 3 by 5. So probability will be 1 by 2 into 3 by 5, that would be 3 by 10. So the first case, what first case we have made? Drawing one ball from U1 and that ball is white. So how many cases would be there? Cases would be drawing one ball from U1, which is white. This would be the first case. What will be the second case? अरे यार कॉपी नहीं हुआ. The second case would be drawing one ball from U1 which is black. What will be the next case? The next case would be drawing two balls from U1. Two balls from U1. Drawing two balls from U1. They could be white, white, right? This would be the next case. And here there would be total 4 kind of cases. So these will be those 4 kind of cases: white, 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 black. So these cases I have written here, right? Red, अरे भाई red क्यों कह रहा हूँ मैं? Red, okay, sorry guys. The ball is red, white, black. Which color is there? That is confusing. White, red, white, red. First ball is red, second is white, and first ball is red, second is also red. So drawing one ball from U1 and that ball turns out to be white, that is 3 by 5. So total probability will become 3 by 10. I am calling this as event x1. Okay. Next, drawing one ball from U1 and that ball turns out to be red. The probability is 2 by 10. I am calling this event as x2. 1 by 2 into 2 by 5. 1 by 2 into 2 by 5. Right? Probability of drawing a red ball, that is 2 by 5. And let's not write down 3 by 5 here, otherwise people will be getting confused. Next, probability of drawing two balls from U2, probability of drawing two balls from U1, probability of drawing two balls from U1. Why I am writing U2 here? Probability of drawing two balls from U1, probability of drawing two balls from U1, and the ball turns out to be white, white. So initially this is your U1, like this is your U1, this is your U1. Initially in the U1 there are 3 white and 2 red, 3 white and 2 red. So this is a simple probability question. If I ask you that I am drawing two balls from U1, what is the probability that I will get first ball as white? First ball as white means 3 by 5. Then how many balls I am left with? 4 balls I am left with. And second ball also white. How many whites are there? 2 whites are there. So 3 by 5 into 2 by 4. Say yes or no. So probability will be 6 by 40. Right? Understandable? Drawing two balls from U1, first one is white and second one is red. So first one is white. First, initially I am having 5 balls. 3 of them are white. Then I am having 4 balls. 2 of them are red. 6 by 40. First one is red. First of all, I am drawing the ball from U1. Drawing 2 balls from U1, probability is 1 by 2. Initially I am having 5 balls. Out of them 2 are white. Out of them 2 are red, and now 4 are left. 3 of them are white. So again 6 by 40. Again 1 by 2, multiply with, I am drawing red. So initially I am having 5 balls, 2 of them are red. Now I am having only 4 balls, only 1 of them is red. So answer will be 2 by 40. Is that understandable to you or not? Okay, let's understand it again. Drawing ball from U1, probability 1 by 2, 1 by 2, this is not a problem. First ball is white, second ball is white. Out of 5, 3 balls are white. Now I am left with only 4 balls. Out of them only 2 are white. Now first ball is white, second ball is red. I am having total 5 balls initially. 3 balls are white. Now I am left with only 4 balls. Out of them 4, 2 balls are red. Red, white. Initially I am having 5 balls. Out of 5 balls, 2 are red. Then I am left with only 4 balls. Out of them 3 are white. What about red? Initially I am having 5 balls. Out of them 2 are red. Then I am left with only 4 balls. 1 of them is red. So these are the probabilities. I am calling this event as x3, this event as x4, this event as x5, and this event as x6. I know it is a very tough question. I already know it. Okay, but who knows, this kind of brain also you might be using. So what they are asking, find the probability that ball drawn from U2 is white. Ball drawn from U2 is white. Okay, so now what are the chances that what they are asking, ball drawn from U2 is white? Let's just say event y1 is ball drawn from U2 is white. Ball drawn from U2 is white. Ball drawn from U2 is white. This is your event y1, right? This is your event y1. Ball drawn from u2 is white. So you are supposed to find out probability of y1 by x1. Sorry, no. This is what we are supposed to find out. No, you are supposed to find out probability of y1 only. You are supposed to find out probability of y1 only. You are supposed to find out probability of y1. Now you know that these many events are there: x1, x2, x3, x4, x5, x6. These 6 events are there. These 6 events are there: x1, x2, x3, x4, x5 and x6. I know their corresponding probability as well. All of them will be going to one guy, which is y1. So probability of drawing a white ball, this was your u2, this is your u1. This is your u1, this is your u2. In u2 initially there is one white ball. From here to here you are transferring. So what is y1 by x1? Probability of y1 by x1. What will be y1 by x1? Probability of drawing a white ball. Probability of drawing a white ball given that one white ball is transferred. So from here one white ball is transferred. Now here how many white balls you will be having? 2 white balls. Out of them how many of them are white? 2 of them are white. So what will be the probability? This probability will be 1. Did you understand this point or not? Given that you are transferring a white ball, what is the probability that you are drawing a white ball only? Draw only white ball. You are transferring a white ball. What is the probability of drawing a white ball? In the box, both of the balls will be white only. No, so probability will be 1. Second question. Probability of y1 by x2. y1 by x2. y1 by x2. What is the meaning of y1 by x2? Given that you are transferring a red ball. Given that you are transferring a red ball. So here total 2 balls will be there. What is the probability of getting a white ball? That will be 1 by 2. 2 balls will be there, 1 red would be there, 1 white would be there. So what will be the probability? That will be 1 by 2. Next, x3. Given that you are transferring 2 white balls. Given that you are transferring 2 white balls. 2 white balls I am transferring. What I am transferring? 2 white balls I am transferring. 2 white balls I am transferring. So total how many balls will be there? 3 balls will be there. Total 3 balls will be there. Out of them, how many of them will be white? Only 3 of them will be white. Why is that so? Because you are transferring 2 white balls. 1 white ball was already there. So all 3 balls are white. So what is the probability of getting a white ball such that you have transferred 2 white balls? The probability will be 1. What is the probability of getting a white ball? What is the probability of getting a white ball such that you are transferring 1 white and 1 red? Such that you are transferring 1 white and 1 red. What is the probability of getting a white ball? So total balls will be 3. Total balls will be 3. And out of them, how many will be white? 2 of them will be white. Answer will be 2 by 3. What is the probability of getting a white ball given that? What is the probability of getting a white ball given that you are transferring red white? Again the same answer would be there, 2 by 3. So red white you take, red white you take. So total balls will be 3. Out of them 2 of them are white. What is the probability of getting a white ball given that you are transferring both reds? That means you are transferring both red and red. So total balls are 3. What is the probability of getting a white ball? That will be 1 by 3. So this is the level of this question. This is the way this question has to be solved. Are you able to understand this point or not? Okay. And then these corresponding probabilities we need to write down. So I solved this question. Who knows? Like this one question is like 10 small questions, right? This one question is like 10 small questions. You are revising everything here. Conditional probability you are revising. You are revising total probability as well. You are revising Bayes theorem. Everything you are revising here. So that's why I thought that let's take this question because everything will be revised. In the GATE examination, such questions will not come because for one question you are getting 3 minutes. But in JEE Advanced, these kind of question would come because there you get higher time as well and you don't need to score too much of marks as well. Right? So there, these kind of questions will be treated as tough questions. Those who solve it, they will get the marks. Those who don't solve it, they can drop it. So JEE Advanced would ask these kind of questions, but GATE will not ask these kind of questions. GATE may ask this kind of question. This kind of question. Now, after solving this question, after solving this particular problem, this will feel like a cakewalk to you. So this kind of question could be coming in GATE. So that's why we are solving such bigger questions so that we will be comfortable in any kind of question in the examination hall. Understandable? So now this question has been solved. You just need to write down the corresponding probabilities. 3 by 10, 2 by 10, 6 by 40, 2 by 40. 3 by 10, 2 by 10, 6 by 40, 6 by 40, 6 by 40 and 2 by 40. And such questions should be solved with patience. Okay. When we were preparing for JEE Advanced, there was no one to guide us, right? So these kind of questions we would try to solve in a very quick manner in the examination. But all these questions require patience, very patience, like keep on writing down the theory and some theory you will write down, although not complete theory you will write down in the examination hall, but some theory you will write down. Here I am explaining you, that's why I am solving in this manner. And wherever I have checked the solution of this particular question, they have solved in some different way. Okay, some are applying this theorem, that theorem, but we can solve it with proper intuition. No base theorem, no probability, nothing. Proper intuition, right? So 3 by 10 into 1 plus 2 by 10 into 1 by 2, that would be 2 by 10 into 1 by 2 will be 1 by 10 plus 1 into 6 by 40 plus 2 by 3 into 6 by 40. 2 by 3 into 6 by 40. That will become 4 by 40. Okay, I don't want to disturb this 40. Okay, so this will become 4 by 40. I did 2 by 3 into 6 by 40. So 4 by 40. Then 2 by 3 into 6 by 40 will be 4 by 40 only. Plus 1 by 3 into 6 by 40, that will become 2 by 120. Now it has been disturbed because 1 by 3 into 2 by 40 will become 2 by 120. Okay, so this we are supposed to solve. So 4 by 10 plus this has become 4 by 10. This has become 10 by 40. This has become 6 plus 10, 14 by 40 actually. 14 by 40. 4 by 10, 14 by 40 plus 2 by 120. Okay, so let's solve it. 4 by 10 is 2 by 5 plus 7 by 20. First I thought that I would not be changing the variable, but choice 3, 21 plus 1. So 46 by 23 by 30 is the answer. Okay, when you solve it, you are getting 23 by 30. Answer is 23 by 30. That's the answer that you are getting. This is the answer. Okay, 23 by 30 is the answer. Answer is 23 by 30. That's the answer. So did you understand this question or not? Whatever the process is there, just keep on thinking of the process. Sir, corresponding probability I can find out. 1 ball I can draw, 2 ball I can draw. So first of all, you need to think 3 processes going on here. Head, tail. So when you will draw 1 ball, when you will draw 2 balls. When you are drawing 1 ball, it could be white, red. Again, yaar, red to nahi likha, haan, red likha hai. In the question also it was red only, yeah. So it could be white, red, or white, 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 red, white, red. So this 6 process is there. You are transferring 6 kind of process, either white or red or white, white or white, red, white, red. You need to find out their corresponding probability. That corresponding probability we have find out. Now you need to find out the conditional probability. Here the question was probability of receiving y1. This was the question. So after that, what you are supposed to find out? You are supposed to find out the conditional probability. That means probability of y1 by x1, y2 by y1 by x2, y1 by x3. So just make the boxes, just make the bags, and you will be able to understand that if I am transferring only one white ball, then what will be the probability? If I am transferring one red ball, then what will be the probability? If I am transferring white, then what is the probability? White, red, what is the probability? Write down the corresponding probability and then solve it. Answer is 23 by 30. There you go. A very good question, but hopefully such kind of questions will not come in the gate examination because they are very tough. But again, for concept building, this was the best question for concept building. Understandable? Let's go to the next question. This you should be able to solve on your own. A girl is throwing a fair dice. Again, it is a J advanced problem only. If the outcome is 5 or 6, then she will toss a fair coin 3 times and record the number of heads. And if the outcome is 1, 2, 3, 4, then she will toss a fair coin 1 times and record whether the head and tail is appeared. Find the probability that she obtained exactly 1 head. Given that she obtained exactly 1 head, find the probability that die showed 1, 2, 3, 4. Okay. So I am making an event x1 such that die showed 1, 2, 3, 4. Die showed 1, 2, 3, 4. And then event x2 I am making that die showed 5, 6. y1 I am making, she obtained exactly 1 head, getting exactly 1 head. No, it is not J advanced. If it was J advanced, I would have written it. It is not J advanced problem. I remember this is J advanced problem. This is a random question. Okay, this is a random question. What you are supposed to find out? You are supposed to find out that given that she got exactly 1 head, find the probability that it has come from die showed 1, 2, 3, 4. This is what you are supposed to find out. That means, sir, it would be equals to probability of y1 multiply with x1 by y1 would be equals to probability of x1 multiply with the both of them will be equal. Okay, so this is something I am supposed to find out. This is something I am supposed to find out. This value, sir, I am not having. Probability of x1, probability such that die is showing 1, 2, 3 or 4, 1, 2, 3 or 4, 1, 2, 3 or 4, 1, 2, 3 or 4. The probability will be, sir, 4 by 6, right? And the probability such that die is showing 5 or 6, that will be 2 by 6. So probability of x1 is 4 by 6, probability of x2 is 2 by 6. Understandable? So these value 4 by 6, 2 by 6, x1, x2 we know. Do I know this particular thing? What is this particular thing? Probability of y1 by x1. Probability of y1 by x1. So read it carefully. Such that die is showing 1, 2 or 3 or 4. Find the probability given that die is showing either 1 or 2 or 3 or 4. Find the probability that you are getting exactly one head. So if die is showing either 1 or 2 or 3 or 4, then what you are doing? If die is showing two kind of process is there, 1, 2, 3, 4 and 5 is 6. So either 1, 2, 3, 4 is showing, then she is tossing the coin once. She is tossing the coin once. That means either she will get head or she will get tail. Either she will get head or she will get tail. And if 5 or 6 are being shown, then she is tossing the coin 3 times. So what are the possible results? The possible results would be, sir, head, 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 tail, head, tail, head, head, tail, tail, or tail, head, tail, 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 head, tail, head, head, tail, tail, tail. These are the possible results. Okay, these are the possible 8 results. So what you are supposed to find out now? You are supposed to find out that getting exactly one head, given that die showed 1, 2, 3, 4. That means if die showed 1, 2, 3, 4, then what is the probability of getting exactly one head? That is 1 by 2, no? That will be 1 by 2. And what will be the value of probability of y2 by x1? Although I am not sure whether you are supposed to find out or not. What is y2? y2 is not even given. y1 by x2. What is the probability of y1 by x2? What is the probability of y1 by x2? That means if die is showing 5, 6, then what is the probability that you will get exactly one head? Probability that you will get exactly one head. Exactly one head here, exactly one head here, exactly one head here. So what will be the probability? That probability will be 3 by 8. Probability of getting exactly one head such that 5 or 6 are shown. So that would be equals to 3 by 8. That would be equals to 3 by 8. So this particular thing also we know now. So probability of y1 by x1 we know, probability of y1 by x2 also we know, x1, x2 also we know. So let's try making the diagram. x1 is there, x2 is there. Let's remove this. Okay, x1 is there, x2 is there. Probability of getting x1 is 4 by 6. Probability of transmitting x2 is 2 by 6. That means you are tossing one fair coin or you are tossing 3 fair coins. You are tossing one fair coin or you are tossing 3 fair coins. You are tossing 3 fair coins. Here you are tossing one fair coin and here you are tossing 3 fair coins. So you are tossing 3 fair coins in this case. So probability of tossing 3 fair coins is 1 by die showing 1, 2, 3, 4. It is equivalent to tossing one coin. Tossing one coin, right? And this is equivalent to tossing 3 coins, right? So what is the probability of tossing one coin? Sir, probability of tossing one coin will be equivalent to probability of die showing 1, 2, 3 or 4. That will be equal to, sir, 4 by 6. What is the probability of tossing 3 coins? So that would be equal to die showing 5, 6. That will be equal to 2 by 6. So this we have written. Now what is the probability such that you are tossing one coin? What is the probability such that you are tossing one coin and you get exactly one head? So that would be 1 by 2. And what is the probability that you are tossing 3 coins and you get exactly one head? So that will be 3 by 8. Understandable? So what is the probability that you will be getting? Probability of y1 we are supposed to find out? No, here we are supposed to find out probability of y1. So what is the probability that you will be getting exactly one head? So that will be 1 by 2 into 4 by 6 plus 3 by 8 into 2 by 6, right? So 4 by 12 plus 6 by 48. 4, 16 plus 6, 22 by 48. 11 by 24. So 4 by 12 plus 6 by 48. 22 by 48, 11 by 24. So probability of y1 is 11 by 24. Probability of y1 is 11 by 24. So that we have understood. Probability of y1 is 11 by 24. So from here what I can see, 11 by 24 multiply with x would be equivalent to probability of x1, that is 4 by 6, multiply with probability of y1 by x1. y1 by x1 is 1 by 2. Okay, 8 by 11. That's the answer. What is the answer? 8 by 11 is the answer. There you go. So this is how we are supposed to solve these kind of problems, which are considered as very tough, but it is very straightforward. What is the process we are doing? So tossing one coin, tossing three coin. Probability, corresponding probability you write down. Then you write down their conditional probability. That if you are tossing one coin, what is the probability of getting exactly one head? That will be 1 by 2. If you are tossing three coins, then what is the probability of getting exactly one head? That will be 3 by 8. So 1 by 2, 3 by 8 here. Okay. This flow diagram, you know, you will be able to find out probability of getting exactly one head. Now probability of getting exactly one head you have written. Now what you are supposed to find out? You are supposed to find out that it is given that she has obtained exactly one head. What is the probability that the die showed 1, 2, 3 or 4? Okay. So what is the probability that we have found out? 8 by 11. Is that clear to you or not? Surely it is clear to you. Understandable? Let's go to the next question. This is a GATE QIQ only. Is it related with the Bayes theorem or total probability? I don't know. You try solving it. If this question is coming in your examination hall, will you be able to know whether it is Bayes theorem, total probability? Read the question. A couple is having two children, assuming that each child is equally likely to be boy or girl, and the genders of the two children are independent. Find the probability that both of the children are boys, given that at least one of the children is boy. Then find the probability that both the children are boys, given that elder child is boy. So if a couple is having the children, what could be the probability? That sir, first child, I am writing first child, and then I am writing first child, and then I am writing second child. What is the meaning of first child? That means this is younger, and this is elder. First child will be elder, no? So this guy will be elder, and second guy will be younger, right? So what they are saying, this is the way I am writing down. So what could be the possible chances? What could be the possible chances? That sir, first guy was boy, second guy was also boy. Sir, first guy was boy, second was girl. Sir, first one was girl, second was boy, and then sir, first one was girl, second was also girl. These are the chances. Now what is given in the first one? Given that at least one of the children is a boy, at least one of the children is a boy, at least one of the children is a boy, at least one of the children is a boy, at least one of the children is a boy. That means there are total 3 chances. At least one of the children is a boy. Then what is the probability that both children are boys? Both children are boys. Only one chances are there. Out of 3, only 1 chances are there. Answer is 1 by 3. Second, the probability that both children are boys, given that elder child is boy. 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 Only 2 chances are there. Out of them, what is the probability that both of them are boys? Only 1. That's it. This is the answer. 1 by 3 and 1 by 2. It is a GATE QIQ only. Okay. A lot of people, this question was asked actually in GATE. So a lot of people marked 1 by 2. Why is that so? Because they thought that these 2 cases are same only. Both of the cases are same. That whether you are having boy girl or you are having girl boy, both cases are same. But you need to take care of elder and younger as well. Okay. Always when the question is coming on children's, no, so always take care of the case elder younger as well. That first child is boy, second child is boy. First child is boy, second child is girl. First child is girl, second child is boy. First child is girl, second child is girl. So total 4 cases are there. Now what they are asking, given that at least one of the children is a boy, at least one of the children is a boy. That means what are the desirable cases? That given you know that one of the guys is surely boy. That means these are the 3 cases only. Both girls is not possible for them. They are saying that both girls are not possible. So given that you already know that one of them is a boy, you already know that one of them is a boy. So what are the chances that find the probability that both children are boys? So out of 3, only one chance is there. So 1 by 3. And now what is given, that elder child is a boy, elder guy is a boy. That means the first child was a boy. Then what is the chances that second child will also be a boy? So it is very simple. No, sir, I don't, whether this was a boy or this was a girl, it does not decide what will be the gender of this guy. So either he will be a girl or he will be a boy. So answer is 1 by 2. Or you can think that probability that both of the children are boys, given that elder child is a boy. So elder child is a boy. There are 2 cases. Out of them, one case would be there where both of them are boys. So only one case is there where both of them are boys. So answer will be 1 by 2. Or you can think in this manner that, sir, first child is boy or girl, that doesn't matter on the second child. Here the probability of being boy will be 1 by 2. Probability of being girl, that will also be 1 by 2. So if I ask you this question, find the probability that both children are girls, given that first child is a girl. Find the probability that both children are girls, given that first child is a girl. That will be also 1 by 2 only. You can think from here, given that first child is girl, that means this is the case. 2 cases are there. Both children are girl, only one case is there. So answer will be 1 by 2. Okay. So in that manner you need to think. Is that clear to you? So very simple question. It's just that I wanted to introduce here, because elder, younger, both 2 different cases we need to take. So that's why I thought that we should take this question here. Understandable? Let's go to the next one. This is also a very good question. So 3 men are there. They independently shoot the target. The probability that they hit the target are 1 by 3, 1 by 4, 1 by 5. So probability that A hitting the target is 1 by 3. Probability that B hitting the target is 1 by 4, and independently. And probability that C hitting the target is 1 by 5. First of all, you let me know P of A plus P of B plus P of C is 1 or not. P of A plus P of B plus P of C, is it 1? No. That means it is not based on total probability, or it is not based on this particular scenario. Whatever the questions that we have solved. In all the questions, you would notice that, sir, whatever that we have written here, no, addition of all of them is 1. 3 by 10 plus 2 by 10 plus 6 by 40 plus 6 by 40 plus 6 by 40 plus 2 by 40. You do it, you will get the answer to be 1 only. Okay. Here also, like all the cases, any question you take, this case you take. Here also, sir, if I have made a diagram, here I did not make, here I have made the diagram. So 3 by 5 plus 2 by 5, answer is 1. Okay. You take this question. So here we need to take all possible cases, whether it is there or it is not there. Whether you are drawing red ball or you are drawing blue ball. So all possible cases we take. But here, if probability of hitting the target 1 by 3, probability of hitting the target 1 by 4, probability of hitting the target 1 by 5, that means it is not based on our probability flow diagram. Now we just need to see the question. Each person fires exactly 1 shot. Find the probability that exactly one of them misses the target. First question, exactly one of them misses the target. Exactly one of them. So what could be the cases? Sir, A is not hitting the target, but B is hitting the target and C is hitting the target. Or A is hitting the target, B is not hitting the target, C is hitting the target. Or A, B both are hitting the target, but C is not hitting the target. So what will be the answer? A is not hitting the target, probability is 2 by 3. B hits the target 1 by 4. C hits the target 1 by 5. Plus A hitting the target 1 by 3. B not hitting the target 3 by 4. C hitting the target 1 by 5. Or A hitting the target 1 by 4. B hitting the target 1 by 4. C not hitting the target 4 by 5. 62. 63. 64. 9 by 60. 3 by 20 is the answer. This is the answer of the first one. 3 by 20 is the answer of the first one. Okay. 3 by 20 is the answer of the first one. Now second question, what they are saying. Second question, what they are saying. Probability of, given that exactly one of them misses the target, find the probability that person who missed was B. Exactly one of them misses the target. Exactly one of them misses the target. One of them missed the target. Then find the probability that the guy who missed the target was B. Then find the probability that the person who missed was B. So person who missed was B. This is what we are supposed to find out, right? So what that would be equivalent to? It is simple conditional probability. We will not go in the diagram and all. Probability flow diagram, there we will not go. So simple conditional probability. So what I need to do, I need to take the intersection. So person who missed the target, was B, intersection, exactly one of them misses the target. Intersection with exactly one of them misses the target. Divided by probability of exactly one of them misses the target. What will be the intersection of this? What will be the intersection of this? Just try thinking about it. Just try thinking about it. What will be the intersection of this? Person who missed was B, and exactly one of them should miss the target. What does that mean? Person who missed was B, and only exactly one of them should miss the target. That means B is not hitting. That I know. B is not hitting. Now, sir, what about A and C? Will they hit or not? Here they are saying person who missed was B. That means B is not hitting. B is not hitting. That means B bar. Okay. Now, sir, A and C will hit or not? So now the second statement you will read that exactly one of them should be missing the target. That means only one guy should be missing the target. That means rest two of them should be hitting. That means A and C will have to hit. That means A is hitting, B is not hitting, and C will have to hit. This is the condition. Is that clear to you or not? Only one condition is there. Exactly one of them should miss, and that guy who is missing, that has to be B, and divided by exactly one of them should be missing, that will be this probability. We have already find out this probability. Let's write down this probability again. This probability will be exactly one of them should be missing. That means A is not hitting, B is hitting, C is hitting, A hitting, B not hitting, C hitting, A, B, C bar. There you go. This is the scenario. So what will be A into B bar into C? So that would be A hitting 1 by 3 multiply with 3 by 4, 1 by 3 multiply with 3 by 4 multiply with C hitting, that will be 1 by 5 divided by 3 by 20 divided by 3 by 20. अरे भाई ये क्या हो गया? Yeah, sorry. Yeah, so if you cancel this, what is the answer you are getting? 1 by 20 divided by 3 by 20. So what is the answer? 1 by 3. There you go. This is the answer. This is the answer. 1 by 3 is the answer. Okay, 1 by 3 is the answer. Understandable? So that's it. This is the end of probability for general aptitude. Probability for general aptitude has ended. Probability for general aptitude has ended. Okay. Next, what we are going to study? We are going to study random variables. Random variables, which is a topic of engineering mathematics. So this we are going to study. After that, what we need to study? In random variables only, there will be a topic called probability distribution. Probability distribution. So this is not a topic of general aptitude. It is a topic of engineering mathematics. Probability distribution. This we will study. Distribution. And then we will study statistics. Statistics we will study. So these are the topics we need to study. So this is done, and these we need to study next. Okay. So we will get started with the random variable now, but for general aptitude it is done. Probability for general aptitude is completely done. Now you will be able to solve all the questions of probability in your general aptitude. Okay. Thank you very much. Happy learning. Let's meet in the next lecture. We will get started with the random variables. Thank you very much.